Okay, we're going to calculate a molecular formula. There's more than one way to do this. We're going to do it the way that you determine the empirical formula first and go from there. If you know a different way, you're welcome to go straight to the molecular formula. These percents are percents by mass. And a formula shows the ratio by number of particles, not by grams. So we need to get these percents in terms of number of particles or moles like we usually use. So to get them to moles, what we do is we assume that we have 100 grams of the compound. 100 makes the math easy. The molecular formula is not going to vary with how much we assume that we have. So that's just going to make it easy for us. If we assume 100 grams, then we know that 54.6 grams of that is carbon. So I'm just taking those percents. Okay, and so this is my gram to gram ratio of the three. I need to get each of those to moles, so I'm going to divide by the molar mass of each one. And I'm going to use a lot of digits. Maybe you notice these don't quite add up to 100, and that's because these numbers are a little bit rough. They're estimated, kind of like this one is too. So we don't want to introduce more rounding into it. We're going to use more digits than usual. When I write these down, I'm going to write down a lot of digits because we know that we're going to end up with whole numbers. So I don't want to introduce more rounding into that. Okay, now we can look and we see this is our mole to mole to mole ratio. So if I wanted to, which wouldn't be too good, I could say my formula looks something like this. But those don't have whole numbers, so that's not good. We don't want to do that. We want to get these to whole numbers, and the way that we do that is by looking at the three numbers and dividing by the smallest of the three. That will help get our ratios to whole numbers. Okay, that makes this one 1, this one 2, and this one comes out to about 4. So there's our mole to mole to mole ratio. So our empirical formula is C2H4O. Okay, but that's not what we were asked for. We were asked for the molecular formula. So let's continue on. So the molecular formula is equal to the empirical formula times some factor. Okay, and we got to figure out what that factor is. Well, what we can do is we calculate the molar mass of this and then see how many times we have to multiply that to get the molar mass that was given. So the molar mass of this is 2 times, and here we don't have to worry too much about sig figs because we're done with that part. And so for this molar mass, I get 44. And then at the top, the given molar mass of this compound was 176. So basically you're asking, what do I multiply this by to get 176? Or 176 divided by 44 is approximately 4. So if we multiply this by 4, we get our empirical formula, which is going to be C8H16O4. I'm sorry, that's our molecular formula.